All right, we're recording this session.
Notice that Nick's crew insisted on being here just so that they could keep him honest. Oh, they wanted to have him.
All right.
Okay, thank you. Okay, so I'm Nick Falkoff. My company is Auburndale Builders. We're situated in Newton. And this presentation is passive house 0 to 60. Okay. I'm the owner and general manager of the company. We have 7 employees, half of which are here tonight. Mike Dutra is going to speak a little later. Mike is the project manager of the passive house we're building in Wayland. And then you'll also get to hear a bit from Mike Duclos, who's working with us as well. Mike, I think you're blocking.
Oh, okay. Try again. All right, let me just try manual again. Second.
Start. Introduction. So the way we heard about passive home building, through the National Association of Home Builders, I'm part of a Builders 20 Club, and Dan Marine at Oak Tree Homes in Iowa was building a passive house, and he sort of turned me on to this. I emailed Mike Dutra from the class to see if he was interested, and he was interested in getting certified. So briefly after the PHIUS Builders course, where he met Michael Hindle, who is our certified passive home consultant. Michael is also the president of PHIUS, which is the Passive House US, Passive House Alliance US, so sort of a branch of PHIUS. So our team started getting very excited about this. Mike took the exam, got certified. We flew about 4 of our guys out to, and Donald, out to the PHIUS conference in San Francisco. We got, sort of started really drinking the passive. I said, Michael, who can we bring in on this project? It's a very high-end custom project. We need the best people. Who should we find? And he recommended I contact Mike Duclos and Mark Rosenbaum and bring them onto our team. So I went to Portland. I found them in the cafeteria. I described the project to them, and thank God they were interested in working with us. That was about, I think it was a little over a year and a half ago. A little under, sorry. So brief history. Mike, this thing isn't working again. See?
Oh, sorry again.
Yep. Sorry. So that's it.
Okay. Now?
There we go. Okay, so what we did, so we wanted to use an integrated project delivery. That's how we wanted to go about this. So we put together a team, Donald Gross, a project designer, Mike Dutra, project manager, Michael Hindle, TPHC, Mike Duclos is our PHIUS Plus rater, and our general, Mike consults us on a lot of battery backup and a 12 kW solar system. Crystal Forge is designing that. Brian Nelson is our site engineer. Tim Holtzcraft isn't here, but Tim is our lead carpenter of the job, who also just took the builder's course. Casey's here, utility carpenter of the year. Tom Rose is another architect we brought in to help with the passive detailing, to help, there was just so many details that we didn't know we needed. We got into it. And then I am the general manager. Okay, so the Wayland Passive House, not passive yet, but the design is in place. So the client says we want state-of-the-art. They had an initial program when they came to us Donald Gross had this program. So these are the requirements we started with. Okay, we started with, it had to be, this is for an older couple, they're both in their early 60s. It was an aging in place home. It had to be accessible. It had to be adaptable for future use. It had to be visitable. It had to be resilient. And by nature, a resilient house, Donald Gross, who is the designer, teaches at Boston Architectural with Alex Wilson. Alex Wilson started the Resilient Design Institute. So Donald is all about resiliency. So we wanted low energy use, low maintenance, able to survive climate extremes. The clients wanted it to be connected to nature, and we wanted the house to be environmentally responsible. So that was the program before they got to the passive stuff. So the client, Frank, did a design. He put on paper how he envisioned what he wanted for his dream house. This was a piece of paper he drew for Donald, okay? And basically you pulled up in a driveway, and it was a long sort of flat house. This was the initial concept. Frank showed some pictures to Donald about what he wanted, okay? He wanted this very steep pitch roofs, French provincial look. As you know, not conducive to passive, not easy to make this passive, but this is what we were starting with, okay? This is the site of the existing house is here, and then this is conservation land that's back here, this wetland, and we had to fit the house in. The lot is very limiting in terms of where we could place the house, working with the wetland boundaries. So this is the design that Donald had come up with, okay? This is sort of right as we're getting involved in the project. So there's already a design sort of in place. There's a lot in place. Mike, you zoomed out on us here.
Oh, I'm sorry. This
No problem.
is really strange.
Yep. So I'll just
sure what happened here. Get back. No.
Swap just
Yeah, I'm looking for the swap back button.
feel free to stop me at any point during the discussion because I tend to talk pretty fast. Okay, so we started out. We had this. This is actually the south side of the house here, and this is facing out towards conservation land this way. So the whole axis of the house was designed to look out this way towards the conservation land. Okay, and early on, we had Michael Hindle did some energy modeling. We did some solar pathfinders, and I'll just keep talking. So the house was not oriented due south. It was about, I think we were 4 degrees off from optimal due south, but the clients did not want to turn the house any more away from the conservation land. So with the energy models, we could have gotten this down to like 1.7 BTU per square foot for our energy, but the clients wanted the house rotated for the view, which was a challenge. Next slide. So this was the layout. We ended up with a sort of long, flat layout. A long, flat layout. You walk into the house. You've got a large living room, sitting area. This was the initial design. It's kind of flipped since then, but it was basically for first floor, they want a long first floor space, very accessible, okay? So this is where we're at. Now we say, how do we make this passive? Okay, so this is the view looking out into the conservation area. It's beautiful. You get, you get beautiful views that they weren't willing to trade the view for function. So Donald's got this. He put this into SketchUp. Donald designs this. We've got this sort of image in mind. Okay, this is how the design evolving. This is the south wall. This is really the front of the house, but this is the south curtain wall. This is where we're going to get all our heat from. Okay. Some more elevation. So we've got a brick house, slate roof, copper, very traditional exterior. Okay, so this is the building going up. These are some drone photos of the structure. So the geometry of this house is very complex. It's not at all conducive to building passive. I've recognized a few of you from the Nessie tours. So this is really the opposite of what you want when you're building a passive house. So I'm going to give you a little history on how we organized our team. Now how are we going to make this thing passive? So this is from a PHIUS builder's training course. So they recommend that you have an architect engineer, you've got the estimator, your builder mechanic, your purchasing, your CPHC, and your project manager, and you're all working towards this common goal, which is how do we get this thing to be passive, okay? In reality, we have about 10 more rings going on there, and it's a job to help us all sort of work towards how we're going to get this to meet the standard. Oh, Mike, this thing isn't working again, sorry. Okay, so I'm just going to give you a brief history. So this is traditional project delivery. So traditional project delivery, you know, you bring the architect on, he does the design, the engineer engineers, you bring in the general contractor later on, and then gradually you bring in the major trades, okay? And as you're working through this, basically the common understanding of what we're building and what we're trying to achieve, everybody doesn't really understand what's happening until the end of the project, okay? Like the electricians and the painters and the tile guys, they don't know what's going on until like here, okay? With this, the high-end project like this, we did not want to risk failing that we would not reach the passive standard. We didn't want to have infiltration through our air barrier. We didn't want to have somebody mess up our thermal bridging. So we did not want we didn't want that as you go along there'd be any risk of failure. So we're using integrated project delivery, which is we tried to achieve common understanding of all parties is achieved early in the design. So as soon as we had the design and we had an energy model, we brought in all of our major trades. We brought in our plumbers, our electricians, we brought in our masons, our site work contractors, and Michael Hindle did an on-site training to introduce them all to the passive concept and tell them, this is what's different. You've never worked on a building like this. This is what's different. This is how we're going to achieve this. This is what happens if you put a hole in our balloon, the whole balloon, the hot air balloon's going to pop. This isn't going to fly. So, this is ideally, so we brought everyone in early, and then the risk for failure is less because everyone understands what's going on, and there's a less risk that we're going to fail in terms of meeting our passive standard. Okay? Slide. So some of the challenges that came up with this, okay, is that one, everyone has to have confidence in one another. We've got a lot of people who have not worked with one another. This isn't your standard, architect and builder working together. We've got 10 other people involved. It's been a challenge to incorporate the building science into the design because a lot of the subs, we're doing a lot of on-site training, and we're doing a lot of education as we go. Coordinating remote consultants. This has been a real challenge and something I would recommend if you're considering hiring remote consultants. So Mark Rosenbaum is on Martha's Vineyard, Chris LaForge is in Wisconsin, Michael Hindle is in Maryland, and we're on site trying to build this thing, and Mike's trying to get answers for things. If you're going to use off-site consultants, they're excellent, they're great, bring them on site as soon as you can so they can understand the physical characteristics of the building and the site. So we just had Mark Rosenbaum hadn't been on the site until a year into the job, and it really changed the conversation. So that's something that if I had known early on that, the challenges, I would have invited them out, and it would have been well worth the cost of the flight and the hotel just to avoid the redundancy in terms of the amount of emails that have gone through that could have been done in face-to-face interaction. Other challenges, identifying group roles. So because you've got so many people at the table early on, it was a challenge for me. I started to see that a lot of people weren't used to this, and they were really starting to get outside of their spheres of what their specialty was. They felt because they're at the table, they needed to talk about what everyone else was doing. So part of my role has been to make clear when someone's brought onto the team, here's your role, here's what we're looking for, and please, if you have a concern about somebody else, you can bring it up to me, but try to, we've gone through 3 interior designers, we're on a 3rd interior decorator now, because they just couldn't work within the parameters we were setting. They couldn't work within the team structure. So that's, just be very clear about what you want from each person as you bring them into the team. And the way we've been doing that is we do weekly client meetings. So each week we sit down with the clients and we go through their decisions. And we also do a weekly technical meeting to manage the form and function of the interior and exterior finishes. So Mike, myself, Donald, and impact the passive details. Okay, so a bit about our process. So I'm going to introduce Mike. Mike is our project manager, and I call our chief problem solver. That's his office. I took a picture of him. Whoops, sorry. That was last year during the winter, and we had 3 feet or 9 feet of snow. I took a picture of Mike walking across. So Mike is really the one who's dealing with the day-to-day managing. We'll have 30 trades on site some days, and Mike's going to talk about some of the challenges that came up in this project so far, which we're only just getting into rough wiring and plumbing right now, okay? And what are the challenges that came up that we didn't know about, like that we couldn't have anticipated, and how have we sort of worked through them and the solutions we've come up with? So with that, I'll turn it over to Mike.
How long has it been under construction so far?
We've been under construction for about a year at this point. So we started digging the foundation last winter. So right when we were having all this snow, the client said, I want us to dig regardless of the snow. So we started about a year ago, and we are now, you know, the slate is on the roof, the brick is about 80% done, and the building is rough wired, the plumbing has just started, and the HVAC has just started. So we probably got another 4 to 6 months to go on this. So with that, I'll turn over to Mike. So Mike, this is the laser pointer. That's their slide to go forward.
Okay. Yep. So as you can see, started in winter, 5 feet of frost. Had to bring a hammer. Homeowner didn't want to stop. Had to keep going. Very challenging. A lot of cold days and cold nights for me and Casey, putting down hay and thermal blankets, and you all know what winter was like last year. So we did put a foundation in last winter, which was very trying. A lot of the details, obviously, this is my first pass of house, so working with Roxel, working with all these different materials that I'd never worked with before. The first time I've ever put foam glass under a foundation form before. That was an interesting concept, you know what I mean, to figure out how to put that in. And once again, it wasn't a challenge of the winter time. There weren't a lot of available materials. I mean, we would like to use maybe stone dust or a nice sand underneath there, but we couldn't get a lot of that stuff. Everything was frozen solid. Most of the places weren't even open because they were shut down for the winter. So it was very difficult working on the foam glass and just coming out with how to cut it, how to install it, how to, you know, all those details. I was lucky with Michael Hindle, had a lot of good friends at Foam Glass, so I was able to deal with them and call their, you know, rely on those people to help me with some of the details to figure out how to do a lot of this stuff. The masonry, another lot of details because the assembly had to breathe, so working out the flashing details, the ventilation, the weeps, you know, how the whole system was going to work together. We have 12-foot windows, which are more difficult because now we have a 12-foot span that is not going to vent straight up, so we had to figure out how we're going to vent that area and still make it look, you know, beautiful. So, you know, there's a lot of issues with that. And then working out all the details. We have 12 inches of Roxel underneath the slab in the basement. So I've never, you know, put that much insulation under a slab before, so that was, you know, interesting to figure that out. We also thermally broke the slab all the way around the whole inside with 4 inches of foam glass. We also had the issue with, when we first started, we dug out in the backyard and we hit water. It is wetlands there, so that was a big concern of mine because the foundation was going fairly deep into the ground. So we ended up meeting with the engineer, Donald, Nick, myself, and we raised the house another foot out of the ground because of that concern. And we ended up putting 18 inches of crushed stone underneath the whole house before we built on it. We ended up doing that just to make sure we had enough for the water to get out, because the wetlands, we've been fine right now. We haven't had any water, you know, because I think we've taken enough measures to make sure we don't have any water. So it's, you know, it's been, it was well worth that decision. But we also had the problem with, when we did do the site excavation, we almost had 2 to 3 feet of loom. Well, because of that, the house was almost floating on one side, the ground, because we had to get all that material out. We couldn't build on that. So we ended up going with a full foundation where the middle of the house was only supposed to be a full foundation. We were supposed to have slabs on grade in the other locations with a crawl space. So we ended up having to change the whole foundation details and go to a full foundation. So that was a lot of changes. So as you can see, we have 20-inch TGI roof assembly. And then we patted it down here with another 2x4. So our joist bays are 24 inches by 24 inches, 2 foot on center. And then we have 6 inches of Roxel on top of the roof. Then we have a pressure-treated 2x6 that runs vertically with the I-joist, and then it's strapped over the top with 20-gauge straps to basically hang it on the roof so that that assembly can't move. Because you're going through 6 inches of Roxel, a 2x, and then by the time you get that 10-inch screw in there, I mean, there's so much ability for deflection. I mean, you're only biting into that thing a few inches, and you got more out than you got in. So the engineer wanted to strap everything. So everything's kind of strapped and like hanging on the roof. And then we have 3/4 plywood over that again. So our roof assembly is just a little over 30 inches thick. So we had the fire department out there. I go, don't bother bringing an axe. You're not going to go through this house. You know what I mean? This house is like bulletproof. So all of our soffits on the outside are mechanically fastened, so our roxel runs up 4 inches on the exterior, turns into 6 inches over the top, and carries over the whole building. 4 inches of roxel runs all the way down to the foundation, but our foundation is below grade on this house. This house is fully accessible. So we put 4 inches of foam glass against that area, and then started the roxel on top of that, so that we would have them, and we did like 3 different measures of counter flashing to prevent any water or moisture from getting into that location. And then we have 5 inches of roxel on the outside of the foundation, which wraps down the footing, 6 inches of foam glass underneath, and then we have the 12 inches of roxel underneath with the 4 inches of foam glass going around the whole perimeter. All the footings inside, the spread footings, are all have foam glass under them. They're wrapped with roxel as well, and then we actually put foam glass around all of the columns in the basement to thermally break those. And also, if anything was to happen, you'd be able to dig that foam glass out of there, replace those columns, or make any changes you need to make, and without getting into the whole, tearing up the whole basement floor. So that, because the basement's unfinished, so the homeowner was fine with that. We have a drainage system with 4-inch drainage pipe running all the way around. This detail really doesn't show what everything that's going on there. And that runs out to daylight to the cornfield. On top of that, we have a layer of stego wrap, and then on top of that, we have another layer of 4 inches of crushed stone, and that's our radon layer. So we had to separate our drainage layer from our radon layer because we'd be sucking the whole house if we tied those two together and the outside. So I worked with a gentleman that Mike Duclos introduced me to from the Massachusetts Health Department about radon. He's the chief engineer, so he came out to the site and we worked out one afternoon a system for doing that to separate all that. So it was great to have his expertise to help me with that. So basically, this is the job in the middle of the winter. The guys are putting down working on the foam glass. Because of the footing being 36 inches wide and the foam glass being 6 inches deep, and then 12 inches of concrete, we had to take 24-inch forms and stand them sideways. And I'm still hearing from the form guy about all the staples we had to put in the slip sheet over the foam glass, so when we poured the concrete wouldn't seep into the pores of the foam glass. There's the thermal break from the octagon room, the sunroom, from the rest of the house. So what we did is we stood up foam glass and we made basically a wall or a form. And I have to say, that foam glass withstood the pour of concrete, and the actual forms around the outside of the octagon that were all plywood and wood gave way. And that stayed with just the mastic and the way we assembled it, which was pretty phenomenal. And I was a believer in their mastic after that. So there's the guys, a couple of the framers. They helped us out with a lot of the stuff. You know, as you can see, there's it's over 500 lineal feet of wall and 5 inches of foam of roxel. That was another challenge. I've never worked with roxel, so I'm like, how do I fasten this? So I was lucky to meet a man from Ramset, and he actually gave us a couple guns. When we had guns break, he loaned us guns, and he introduced us to the Ramset fasteners, the Insulfast. So basically, it's a cordless tool, battery, gas powered, fired, and you get the fasteners from 2 inches up to 6 inches. So we have 5-inch fasteners for the basement, and we had 4 inches for the walls, and 6 inches for the roof. And roxel requires 5 per 2x4 sheet. Basically, 2 top, 2 bottom, 1 dead center. That's the requirements for roxel. Let's go back to that. So now we don't have the slide, but I have drainage around this whole house. I had to pick up all of the gutters on this whole house. We're capturing all the water. We have two 2,000-gallon cisterns, one on the side of the garage, one on the side of the master, and we're capturing all the rainwater. The clients want to use that to do watering or whatever need to have outside. So now I have 5 inches of rock fill, and I have no way to fasten all that pipe around the house. So I actually came up with an idea with the guys, Casey, Tim, and we used straps, and we used these fasteners, and they held up the 6-inch pipe until we could put the crushed stone in there and permanently set it. So these fasteners will hold quite a bit, and they're real easy to work with.
Can I just ask you a quick question?
Sure.
Do you put any waterproofing on the exterior?
The whole outside of the foundation was waterproof.
But not outside of rock fill?
Nope. Nope. And actually, I can tell you right now, I have holes drilled through the foundation for the solar coming in and stuff like that, and we've had all this torrential rain, not a drop of water in the house. I mean, the rock fill pretty much doesn't really absorb it, it kind of just runs off it, you know what I mean? And when we did the foundation, as I said, we did it in the winter. So right coming out of the winter was like the beginning of April, and we still had snow on the ground, you know, the winter didn't end. But I was ready to get going on the foundation, so we had them come out and seal the foundation. Well, that was the one day that we got it was like almost 70 that day and sunny. It was so hot with the sun, and the foundation was so cold that all of the outside film bubbled on the waterproofing. So I had to call up the waterproofer. I did my own research on it, and I read through their pamphlet of what, and they said that it basically failed. Because basically the skin on the outside was drying faster than the chemicals and the gases could get out, and that's what caused the bubbling. So they came back and sealed it a second time with even a better product, their top product they use. So this foundation is beyond waterproof. You know what I mean? That's probably, I'd say, 20 mil thick by the time they sprayed all that on there. So it's pretty watertight. And I was happy for that because I still have concerns about water in the house. So.
Hey, why don't you talk to the benefit of insulating the basement on the outside?
I would have to defer to Michael Hindle on what the benefit is. I've never did that much insulation on it outside. You know what I mean?
You would ask Michael Hindle. I was not part of that portion of the design.
Okay.
What do you feel about it?
I would never do it, but it's just wondering.
Okay. Yeah, no.
It seems like it's a lot more work, a lot more money. A basement that doesn't get used, it's kind of a recipe to do it, to include it.
Right.
We take weather out of the picture. I can do the basement any time of the year, at any part in the schedule.
Yep.
I don't know. I'm just talking out loud. I mean,
We have it insulated inside too. We also have 8 inches inside.
Of course you do.
Yeah, well, yeah, right. So the basement, when it's all said and done, will be R55 in the walls. And the interior walls on the first floor will only be R54.
I mean, was there anything initially that, I mean, how did you arrive there? Do you remember?
I think a lot of it was because of not turning the house that little bit more.
That would, yeah, rotate, the orientation made all the difference. We had to add insulation everywhere we could. So
we had to add skylights due to that, and it just weren't making it.
They are getting a little bit of extra mileage out of their insulation.
Using the concrete? Or?
Well, because they have a groundwater problem, it's acting as a drainage board, which, granted, they could have used something more economical to deal with the hydroponic.
See, I always have that question too, and nobody's ever been able to give me a good answer. Right? Does this have a high water table? What's a seasonal high water table on the wall? A couple feet?
Yeah.
Right. So that water is going to get behind the insulation, right? It's going to touch the concrete, the water table. If I fill up the soil, water is a very good conductor of temperature. So I spend thousands of dollars putting insulation on, and the water is a highway to get a thermal bridge highway to the concrete. So it's doing everything against what I'm asking the insulation to do when it's sitting in the water. Yes.
that's why they insulated inside too.
No, I know. I'm talking out loud.
Yeah.
That's all. I mean, it's one of those things. They did that up in Vermont too. You know, they had a picture of 6 inches of XPS sitting in 2 feet of water, and the water's, you know, the XPS is off the concrete. The water's sitting up against the concrete. What is it? doing? I'm just asking, that's all.
No, and I
just wanted to have that
understand.
conversation about
I understand your train of thought, and that kind of gets to the whole drainage and the radon system, because that was the big concern. It's because of the water issues there, we did that extra layer of stego wrap and rolled that up the walls to separate the drainage layer from down below. Because how is that 12 inches of Roxel going to dry if that all flooded up under that wall? Now you got 12 inches of Roxel, and when Roxel's wet, it's losing its R value. So now how is it dry? How does that assembly dry? So that's why we went to the, with William Bell, we worked it out, and so basically we have two airtight layers. If you call anything airtight, that's a questionable, statement. But, so we ran that, and then I used drainage pipe again for my...
Show them the slide.
Yeah. So that's the first layer. And then, it's a lot of labor to put 385 bundles of Roxel into the basement before you start framing, because it had to go in there, and we couldn't pour the floors to the footings and the posts in it. So, that was quite a bit of, and the amount of times we had to move that to do the rest of the work was, very labor intensive.
Well, that's why they call you problem solver.
Yeah, exactly.
Underneath the footing?
The stego's wrapped up around it.
Around
Yep.
on the outside?
No, the inside.
It's wrapped around the inside. Yep.
So what we're looking at, this is after you've poured the foundation walls and you've
Yeah, the
got...
foundation's a wall, you got the mitel wrapped over, the framers are actually working on the sills, and we're loading everything in, and the guys are putting down the stego. Because basically we had to, in order to keep going, we had to get all the crushed stone in.
Mhm.
So we had to drop all the crushed stone over onto the next layer of stego in order to get the radon layer and have that be crushed stone, then put the Roxel on top of that, and then pour our slab. It's more our water barrier in this instance. The next layer of stego is really our true air barrier.
Water barrier, because you have the waterproofing on the outside.
Exactly. And we have 18 inches of crushed stone underneath that, and then another 4 inches of crushed stone on top of that when we put the pipes in. So literally you have 22 inches of crushed stone before you can get to that stego. And that crushed stone also runs all the way out to the cornfield. So any, water's going to seek the path of least resistance. So any water that gets under that slab, it's going to run under the crushed stone, and it's going to go down the path to that cornfield, because everything's sloped out to that way.
Provided that's higher than...
So Steve, sorry, to go back and answer your question, we've designed all of this so that this layer, beginning here, all of this is above the seasonal high water table. We've designed this for 500-year flood. So what we're doing is the high water table none of the water should ever hit above this plane. If it does, we're breaking the 500-year flood record. And now, so we started with this layer of stego. This is really your first layer of waterproofing. Then there's 4 inches of crushed stone with a radon mitigation. This is our radon mitigation layer. So what's unusual here is we couldn't pull the air you couldn't do your traditional radon mitigation because you wouldn't pass your pass-flow standard. Right? You can't pull the air out of the building from under the slab and still have drainage.
No. Not to correct you, but
yep.
You can't have your radon and your drainage tied together, because we have two pipes going through the foundation that now tie out to a 6-inch pipe that runs around the whole place. So you'd literally be sucking the whole outside of the house, and you don't want to do that. You'd never, now you're actually like sucking radon if it was into the ground all the way around the whole house. So you have to kind of make it smaller so you're not trying to suck the whole damn the whole yard, basically. So that's what, when William Bell came out, that's what we figured out, that we had to seal that first layer as best we could, and then do the second layer and only be controlling that radon that would come up through that, if we had any radon. I've tested next door, it's almost negligible, and we'll do another test once the house is done.
So your plan on day one is to install a passive vent?
Yes. Yeah.
This is all preemptive, that we didn't want to build this and then find out we had a radon issue.
Understood.
Yeah.
I'm just trying to understand, so you have this waterproofing, but then you have waterproofing on the outside.
Mm-hmm.
Yep.
But this is your primary, you're saying?
Primary, and then the
waterproofing on the outside of the foundation wall, just to keep the foundation dry?
Yep. Okay. And with the seasonal high water table, it would hit and go out to the field you saw in the previous picture.
Yes.
Everything where it drains to is below this layer here. So that field would have to be flooded. We'd have to break the 500-year flood record in order for water to get into our radon.
So you'd have a lake around the house before you got water.
Exactly.
Exactly.
And then if we did get the lake, how do we drain that? How do we drain all the sub-slab insulation? That was our concern.
Right, so if water got through this, now it's into the radon layer, and it's essentially the Roxel is sitting on that layer. So we use drainage pipes. So I ran drainage pipes all the way around. I have 2 sump basins that are that are airtight basins for radon, and those, I don't think you have it. Oh yeah, there we go. So the guys, we put foam glass underneath the basin. We wrapped it all with Roxel because we had to thermal break that because there's another thermal bridge. And see, the radon layer goes in. Well, the main reason for doing that was that, let's say water did get up there. We had that crazy amount of weather, and water pushed up through that first layer of Stego wrap, and it got into that next layer. Well, those drainage pipes, it's going to get into those drainage pipes, and it's going to run into the sump pump. So now we would know by checking the sump pump that we have water in our radon layer. And then I literally had the guys, we built a valve underneath in the first layer. It comes up through the bottom of the chamber, and they'll have caps on them. So if we had that much water, we could actually open the caps in the bottom of those sump pumps, and we could start draining off the water below that slab and pump it off outboard. So that's another way of checking too. And that's what we've done through the whole summer, is we checked that all the time. We looked down in those caps to see if there was water down there. And the only time there was ever water in there is when it rained through the house and went down to the basement, because we suck it out with a vacuum when that happened. And so we never ever had water, even with all the rain we had this summer, in that assembly. So we feel pretty confident that's going to work. So this house has, extremely lot amount of LVLs that the guys had to frame. Basically, the whole roof was framed with a lull. There wasn't a joist that we could put up there that the guys could carry up there by hand. A lot of labor for the guys, in KC especially, spreading 4 inches of crushed stone in a whole 3,000 square foot basement. I will stand up and say that Stego wrap is a pretty durable material, because we dropped that stuff from the excavator over the side of that wall, and that stuff is like bulletproof. And that's how we had to do it. We had to just keep moving around the machine and spreading it, leveling it, shooting it with the laser, and get to that point so we could start framing. There's the roof assembly. Like I said before, we have 20-inch I-joists, 24-inch LVLs on the hips and valleys. Our ridge is 31 inches. We have a 24-inch LVL with a 7 1/4 stacked on top of it. It's not structural. It's strictly there because with the plumb cut is that tall. It's not doing anything structural. It's basically just taking up space for it to nail on. This roof could have been framed with 2x12s. The only reason it's done is because they wanted the insulation value. In the beginning, they wanted 22-inch I-joists. 22-inch I-joists are a California product. It was $6,000 in shipping, and if the framer cuts too wrong, Nick's going on a road trip. So we opted to go with the 20-inch, which were a local product, and we ended up patting them down with the 2x4s. We ended up having a hard time. We couldn't get 24-inch rim board. So we ended up using Advantech 1.1/8 plywood and ripping down and making our own rim boards. And that worked out great for us, because Sudbury Lumber had its stock, which is 5 minutes down the road, and we made our own rim boards for basically the whole house. So there's the geometry. Not many thermal bridges there, right? A lot of corners, octagon room, a lot of jogs, a lot of very interesting framing. Had to make up some custom ways to hang ridges and hips and valleys. We have skylights. Because of the framing, we had to keep them very low in the assembly, because there was no way to get them up any higher because of all the hips and the valleys and how they kind of crash through each other. Here are some of the brick assemblies, which we had to, for our thermal bridging with our Unilux windows, trying to come up with details on how to do everything. We're using pretty much Roxel all around the windows. We're using Roxel underneath the sills. We used cork underneath the windows to raise the windows up so that was less of a thermal bridge. When we framed it, we weren't so positive on how everything was going to work out brick-wise for the coursing, so we overframed the windows an inch bigger than we needed them, and that worked out to our favor, because if you look right here, in one of the meetings, they changed the interior detail to a double sill. So that helps out. We had that extra inch because we had to end up push the windows up. And as a credit to my guys, every window in this house is within 1/16 of an inch. I shot it with a laser myself. The guys did a phenomenal job. The framers did a phenomenal job, because if the framers weren't that good, we would have never hit that. Paul Babineau.
Can I explain something just briefly with this real quick? So something that was challenging, just want to point to. So most passive homes, we couldn't find, with the presentations we went to, we couldn't find people that were using brick. So one of the challenges was, this is the exterior brick, this is the 5 inches of Roxel. We had to keep it so we could vent. We were trying to find ways so we could, if moisture drive came from the outside, drove through the brick, we had to make sure we could vent up and underneath all of the sills. But we also had to make sure that if water got driven into the sills, it could get out underneath the sills. So we spent a lot of time trying to do custom details, and a lot of the work has been spent Mike is doing a lot of this stuff on site, is how do we flash this thing? This is such a non-traditional flashing job, using bluestone. When you see a lot of passive homes, they're using aluminum sills, they're using PVC. You can't, so a lot of what we've run into on this project was, if you're going to do masonry, you got to detail all this stuff months in advance. I mean, Mike's been working on a lot of the stuff on site, which has been a huge challenge. And it's just because a lot of people it's just too expensive. It's too labor intensive.
And so to expand on what Nick was saying there is, we have moisture drive from the inside too. So we have ventilation behind the Delta Dry and in front of the Delta Dry. So that was a big sticking point with Michael Hindle. And we had to work with the Delta Dry scientists and everybody to work out that detail of how we can get air. We needed air behind the Delta Dry, and then we needed air in front of the Delta Dry. So that was pretty challenging, how to make that all work and keep bugs out of there and still make it look nice. I mean, this is it's a brick house, and you're talking, there's 500 feet of that ventilation around the outside. So it took a lot of, time to make those details work.
So this is just a slide I wanted to include. So early problems that we knew people had with early passive homes was just a lack of awareness of the permanent air tightness, lack of high-performance windows. So, when they're first building these, these are the problems people are having. They weren't good energy modeling. There were overheating issues and moisture management. So we knew people had these problems decades ago. And we thought, oh, great, they've got this all solved now. So if we go to the next slide, this assembly is so unusual. We had to work through a lot of these. What the challenge with this house was, well, no one's really building super insulated passive brick homes that are like thermally broken. So like Mike, this is a detail that Mike had to work out, which is, how do you thermally break the bricks from the brick shelf? Nobody's done that. So how do we do it? So this is a detail Mike worked out with Michael Hindle.
Right, so this is high load bearing foam glass, 4 inches and 4 inches on the wall. And then, as I talked earlier about, this is all below grade. I mean, basically right here is the start of our actual bricks that are, out of the ground. So my concern was, if any water got in behind this assembly and drove in there and got down and gets into that framing, we're going to have a serious problem. So we literally counter-flashed this 3 times. So we have flashing that comes down. We used the blue skin over and kicked it out over the Roxel, so any water that goes down there. And then we sealed all of the foam glass, and then we counter-flashed that again with our Delta Dry flashing. So it flashed over that again, and then we filled all the bricks solid up to that layer, up to this layer here. One thing, getting back to, we talked about the air. And Mike Duclos was gracious enough to come by and help us. So at that point, I didn't have any numbers from Michael Hindle on what number I was shooting for that size of the house. So we started playing around with it, and we got it. I think we ended up around 640, 670 we would get.
CFM.
Right, at 50 pascals. So I'm like, is that good? Is that bad? So we texted Michael Hindle, and we were supposed to be at like 613 to meet the standard of, 0.5 at 50 pascals. So like, okay, so Mike walked around with us, and Mike's very insightful because, you know, he tells you, you know, check for this, look for this. And one thing I learned from him is look for the spider webs. And that's one thing he taught me. He goes, where there's spider webs, there's air movement because they like the air. So we found a lot of stuff, and we finally got it down to, what were we at, 0.3. Yeah, 0.3 on the by the time. That was our first test. You know, we knew we had spots to find, and we did that. So to get to that 0.3, we did another blower door test. Well, we did it on a morning, and we used a smoke machine. So I filled the whole house with smoke, and then we turned it on, and we checked around, and then next thing you know, it started raining. So we had all the guys in the house looking for leaks and everything, had the framers inside, and started looking for leaks. So now the house is filled with smoke. It's semi-airtight, so now I got this house filled with smoke. So we turned the blower door around backwards. I had done some makeshift drain system where I'd made holes in the house and drained water out while we were still framing to get it off the floors because the Advantech held the water. So we opened up those holes and we turned the fan on backwards. Well, prior to that, before we turned the fan on backwards, the guys were like, Mike, there's water coming in. When I had that house depressurized, the water was sucking through the half-inch plywood on the exterior of the house. Literally. I mean, the water was coming in all over the place, through the plywood. The plywood is all taped. All the joints were taped with wig gloves. The whole house was taped before we put the membrane over top, because that was supposed to be our airtight layer. We actually flipped the door around, started blowing the smoke out, and me and Tim went outside on the stage and in the rain, and we walked around, and I took videos of sheets just bubbling. One 4x8 sheet on one part of the house, the whole sheet was bubbling with air coming out of it. And that, at that point, I had to call Michael Hindle, I called Mike, I called everybody. I'm like, all right, guys, now what? I mean, the house, the plywood is leaking. I mean,
Was it plywood?
It was just plywood, half-inch CDX. So anywhere there was a void, anywhere there was like a football, anywhere there was a knot, water and air was coming through it. And so then we ended up putting my coat over the house, and then that kind of solved the problem. But I took videos of it, and you know,
we didn't want to use the zip system because of the vapor permeability. So
Right.
the whole house has been designed to be able to dry from the inside out. So we couldn't use the zip system, but we were operating on the assumption that plywood was airtight, which we could pass the blower door test, but it was very leaky.
Right, which wasn't the case. And after going to Chicago and seeing, I forget the gentleman's house that I think he blew like a 0.1 with zip plywood. You know, he just taped everything, and I was, you know, like, I think zip plywood might be the way to go.
You got a point there. Yeah.
So as I talked about before, we have 6 inches of roxel on the roof, which was pretty interesting to do. We actually the framer found these machetes for cutting the roxel, which were very everything. That's the actual rear of the house.
Okay, I just added this. I added this slide today.
Okay, so when we were out in San Francisco, we sat in on a conference with Joe Seabrook, and he talked about how the top of houses tend to rot the first foot above, especially with insulation. So on this house, we ended up putting holes in between every bay all the way around the house. We did a 2.5-inch hole in every bay, and then we put our MyPel over it. So if any moisture gets up into the top of this house, it'll be able to diffuse through the MyPel up into the Roxel, and then with the way we have the air chase going up through the house, it should be able to dry to the exterior.
Can I just point this out real quick? So this was a concern. We didn't see anybody building 30-inch thick roofs. So we sat on the seminar, and Joe was talking about how everyone switched to these insulated roofs, but he was getting calls for roof failures, and they were going out to homes and taking the roofs off, and they were finding that the top 6 inches of the roofs were rotting. Okay, people saying we don't need to vent roofs anymore. We're insulating these decks. So I'm at the seminar going, oh my God, what are we gonna do? You know, so what they do is, where we have slate, we have it's a vapor open high heat, what did we put up there, Mike? Was it the,
No, the MyPel is what's...
MyPel. We put MyPel, so it's vapor
My
open.
code, excuse me, the My code is what's allowing the vapor to come out of the house.
So on all those ridges of the roof, if moisture gets into that thick assembly and drives up to the ridge, how do we get that out without thermally breaking it? So we've got a vapor open ridge. We've got holes drilled through the plywood so vapor can diffuse out into the all the hips and ridges. The vapor can vent out through there. So,
And I think we'll know if there's an issue thanks to Casey, who was putting in the OmniSense moisture sensors very high up near the ridge. So we'll know if something's happening to the sheathing.
yeah, so we're also concerned with if we do this assembly, which is so unusual. Okay, my concern was, well, warranty issue. You get a call that there's you know, that the heat, we're going to track all the energy use of this building. If we have 24 inches of, initially a dense packed cellulose, it's a ton of weight. We've got 8,000 square feet of roof space. It's a ton of weight pulling down. If we had settling, my concern was, what if we have settling and then there's a gap along the whole ridge? You're going to lose tons of heat through that ridge. So we're putting temperature sensors in all along the ridge, so we'll know if they're settling. And we're using, on the inside of it, the ridge is accessible. There's just Intello underneath it. We can go back afterwards and drill holes and add dense packs. So if we saw that there was a temperature drop or a gap opened up, we can go back and add more insulation, you know, 5 to 10 years down the road if needed. But, you know, this is, again, atypical. And so how do we plan that we might have issues? What are potential failures?
So there's the guys putting on the 2x6s, sleepers, to apply the next layer of 3/4 plywood. So basically that's our ventilation. So we have a, we have a vent down below here, and then the air travels up through and then goes out through the copper ridge vent. And with the slate roof, that should be like a wind tunnel in there, because once that slate heats up, and it's going to just draw that air right up through there. And so, as you can see, nothing goes tight. So all the airflow can go up and run up the areas all the way around. So we kept everything back off of the hips and the ridges so that we had full airflow everywhere. And around the skylights, we kind of did the same thing. We stopped the sleepers up around the skylights so air could come up and get out and around the skylights and still continue up and out of the house.
So what's your R value on top of the sheathing?
On the roof, we have 6 inches of Roxel.
And that's 3.5 per inch, right?
Yeah, I believe so.
Yeah, so PHIUS is concerned.
Like 25.
PHIUS is concerned that we have less than 30% of the outsolation. So PHIUS's concern was, well, what if you get moisture condensing on the MyCoat? So we're showing is we've got all this ventilation. So if moisture condenses on the MyCoat on the roof, it can vent up through that ventilation chamber. So as soon as that slate heats up, it's going to pull the air, and you're going to vent that Roxel out.
In Joe's talk, were any of his
We got
So basically, this is exterior. This is basically the exterior Roxel, which the masons basically they put most of this on because of being able to track where the brick ties had to go. So they made sure that they hit all the studs with the brick ties. So they kind of did a lot of the Roxel on the exterior, and they did all the flashing on the windows and stuff. So they kind of handled that for us, which took a lot of off our plate. There's our brick. We have soldier course, and that's the Delta Dry. We got the thermally broken brick ties, which is another thing we had to seek out and find to make Michael Hindle happy.
Explain one thing here that's different too. So I couldn't find a good section to show you on this, but so what this Delta Dry does is when the brick is a reservoir cladding, when this gets soaked with rain and the sun hits it, that's going to heat up and the moisture is going to drive into the house. So that has to hit the Delta Dry. That goes up, and the Delta Dry, Mike came up with a design where the Delta Dry curls up into that soffit and can vent out just below our soffit. So this dries to the outside, and then moisture drying, if we go back to the slide before, moisture drying from the inside, okay, so the delta dry is going over our roxel. So the moisture dry from the inside, in the wintertime, the moisture is going to dry from the inside out. It's going to hit the back side of that delta dry and it vents out through the back side of the delta dry. So that delta dry comes up and curls under our soffit. So we're getting ventilation where it can dry from both directions, which is, again, it's an atypical detail. Most people weren't using delta dry in this way.
And we also sealed the soffit to the roxel, because we don't want all that moisture to go up into that soffit and sit inside there. Because basically, if that water, if you had moisture vapor going up, we don't want to introduce it into the roof assembly. So we made sure to seal the soffit all the way around. With the PVC, we just made the pieces a lot tighter, and then when they put them on, they fit everything tight to the roxel, and we used a sealant to seal that off. So we wanted those two to be separate cavities.
Yeah, we didn't want the moisture driving in from the brick, going up, and then into the whole rock. Yeah.
So we have a fireplace in this house, not another thing I guess you would typically see in a passive home. We had some very interesting framing. We had to turn the chimney at a 45-degree angle. So the chimney's at a 45-degree angle. We framed that with LVLs. So we have literally 6 LVLs, 16 feet tall. They go down to the bearing wall in the second floor, and then they stick out of the roof. We air sealed that. We wrapped it with the blue skin, and then we put 4 inches of roxel on the exterior of that, and then we did our stucco, not stucco, our veneer brick on the outside of that.
Okay, so we're going to turn it over to Mike. A couple challenges that came up. So with balanced ventilation, so this client, it was a non-negotiable that they wanted the client wanted a wood-burning stove. It was non-negotiable. They had to have it. So our concern was, how do we keep balanced ventilation while having a wood-burning stove? And this is a hot topic of debate at passive house conferences. But basically, we looked at a way that we have, when the wood stove is going, okay, we can be drafting, we have makeup air that's balancing the air so we don't backdraft the wood stove. But because of that, we have more penetrations now because we have a downdraft for the kitchen range and we have a wood-burning stove. So we have 2 more additional vents that are going to be going, bringing in makeup air. Actually, sorry, 4. We've got combustion air for the wood stove, exhaust for the wood stove, air intake for the makeup air, and exhaust from the makeup air, from the downdraft. So we have 4 more penetrations. We were concerned about how are we going to pass our blower door test with these 4 additional penetrations. So Mike Duclos has been doing some home science, which he will explain, for how are we going to test all these assemblies, and Mike will explain what he came up with.
Sure. So thank you, Nick. So I'm both a PHIUS Plus rater and a passive house consultant who has already certified a building with PHIUS. The advantage I have with respect to the other consultants is I live 10 miles away from this project. So I tend to be on site a fair bit, and that's how some things get brought up. But at any rate, we needed a method for passing the blower door test. And if you have, for example, like a Zender HRV that is variable speed, you can turn that up and down and exactly balance the amount of airflow that you want. In this case, like many other things in this building, it's complicated. It's complicated by the fact that we have, in fact, 3 ventilation zones. 1 ventilation zone for the main living space and master living area, a ventilation zone for gathering room, which intermittently has high occupancy and therefore intermittently needs high ventilation rates, and then 2 bedrooms upstairs, which are expected to be very lightly used. So there's no reason to ventilate them all the time. So 3 machines were decided to be used for this. And for air blower door testing, according to the protocol that PHIUS is using, you're permitted to tape off the inlet and outlet of an HRV that is continuously operating. But that's only one of the 3. So then we have 2 ERVs actually, that operate intermittently. You're not permitted to take those off. So what do? Well, one thing that Mark came up with was to use spring-loaded backdraft dampers that open at a certain pressure. And what we arrived at finally in negotiation, I think we've arrived at negotiation, is that for the air tightness testing to meet the 0.05 CFM per square foot of shell area that's required by PHIUS for air tightness, we'll be permitted to tape everything off. But because the concern is building assembly integrity, air moving through the building assemblies, not for the energy. For the certification for the HERS rating, we're not permitted to tape off any intermittently operating HRV ports. So that means the air is just going to go through those at 50 pascals, and we're going to have a high number for the HERS model. For the energy model, we arrived at a negotiation, and negotiation was this. The spring-loaded backdraft dampers will open only at a certain pressure. So assuming that that pressure is very infrequent, and assuming we can measure the amount of air that goes through, taking an average over a month, let's say, we can determine how much air will go through those just because of wind gusts, just because the wind blows hard enough to blow the backdraft dampers open. So for that, I created in my basement an assembly that consisted of a duct blaster, which is a measurement device that can drive air and precisely measure it, and then some duct simulating a duct run, and then a spring-loaded backdraft damper, and then some more duct, and then an iris damper. An iris damper is a precisely calibrated variable orifice. So by checking the pressure drop across the iris damper and knowing the orifice size, we can measure the amount of air going through it. And so then by determining whether or not the ERV is running, which we'll be able to tell by a current tap, when this is in place, we will be able to measure the amount of air that gets past the backdraft damper due to big gusts, take the temperature difference of the air inside to out, and calculate the additional thermal load. That additional thermal load gets added to the 4.75 or whatever it is for Wayland, Massachusetts. And if we're below the number, we pass. So that was the negotiation. So basically, what we see here in blue and red is we have static pressure probe 1 and 2, either side of the backdraft damper, in red. And then in blue, we have the airflow into the duct blaster. So you can see that the pressure goes up to about 15 pascals before much of any CFM, many CFM of airflow happens. After that point, interestingly enough, the airflow can go up quite high, but the backdraft damper resistance, those two static pressure probes on either side, does not go up. This is at odds with the data sheet. This has nothing to do with the data that they present for this backdraft damper, which shows increasing static pressure drop. We don't know why. We wouldn't have known this unless I had built this. So at any rate, I've done 3 excursions with a duct blaster to show the repeatability of this effect. It happens about the same way each time. And then on the way down, as soon as you hit 15 pascals across the backdraft damper, the pressure drops down. So that's what we proposed to PHIUS. We haven't heard back yet, but we think that's how that's going to work. So, more slides?
So yeah, this is part of the challenge with certification. So if somebody would say, you know, I was trying to think about what to present here, we're doing this 0 to 60, what do we wish we knew? Well, I had sat on a presentation where Jordan Goldman was showing different ways to do. He was doing his own homemade duct blasting at a presentation in Portland. It was interesting to see how are people dealing with these different penetrations, and how does that work with PHIUS? I mean, it's all a process, I guess. You know, there's no really to know. Next thing, so part of this whole project, so we've done 2 NESI tours. We've done 2 NESI Pro tours at the house already, and we're going to do another one when the house is done. So next November we'll do the 3rd tour to really open up the house, let people see what we're doing, show the techniques. We joined NESI about 1.5 years ago, 2 years ago, and we think it's a great organization. We've been attending a lot of events, and so the Passive House Massachusetts and NESI community members, they've been key to finding innovative it's been very important assured him throughout that we use this building as a means of teaching for our crew, our subcontractors, and the community at large to use this as an opportunity to open the building up to teach other people and show people. So that's Tom Rose there. Tom is the other architect who's working with us. This is on one of the NESI Pro tours. We'll open up, we do tours, and it's, it's been a great process for us to sort of open up and show, here are the things, I went to a presentation in San Francisco with Brandon Weiss and Tom, what's Tom's name? Anyway, so it was a presentation on an Uber house. It was a passive living building challenge, and it was incredible to me that they were building this house so far beyond anything I knew. And I asked him a whole lot of questions, and he's like, I don't know that, Nick, and I don't know that, and I don't know that. And I went up to him afterwards, asked him more questions. He's like, we're really just trying to figure this out as we go. And I was really inspired by the fact that here he was trying out new things. He didn't know exactly. He wasn't putting on a big show like he had all the answers. We don't have the answers, but we know there's better ways to build, and we're trying to find them out as we go, which it's stressful, but it's also, it's been really interesting for us. So, this is Donald also. This is Donald Gross here. This is my mother on one of the NESI tours. My mother goes to my father. There. So, it's been really rewarding for us to open up our building. I've been on a NESI Pro tour to Declan's projects in Roxbury. Thought it was fascinating. I know Fred's talking about opening up his house. So I encourage you to go to these NESI Pro tours. They're great. And, people have questions for us or any of our staff. Our guys, we've been asking a lot of people questions, and they've been answering us. So we're happy to answer any questions you have. Or if you want to email us, reach out to us. We're happy to, provide the information we can. So that's about it. I just wanted to,
We had the students from Wentworth out. They came out. They were very interested. And I was surprised when we went to Wentworth that they're actually teaching passive. The architect students there are learning passive. These kids are, a lot of these kids are into the passive and into the net zero and stuff like that. And actually, my son will be attending, my youngest son next year will be attending trade school, the same school I went to. And we're gonna have the students out from the trade school. So we'll have the HVAC guys out, the electricians, the framers, the plumbers, and they're gonna do a tour one day to be able to, because basically that's the next phase. They're going to be doing this. That's what these kids are going to be building. That's what they're going to be doing. So to be able to get them, and they were all excited for the opportunity to come out and be able to tour a project and be able to be involved in this. And yeah, we are lucky to have a homeowner that's allowing us to open the house up to these people.
Any questions?
So at the beginning, you had started by talking about your kind of design build process, and I was just wondering about, and it may be that you're not far enough along in the process to say, but the benefit of having your major trades on board from the start, and if you've seen kind of strong follow-through of the information that was perhaps presented to, the owners of the company or the crew leaders, and whether that information has kind of infiltrated down through to the individual, electricians and plumbers who are on the job, or if you've seen any kind of like disconnect. And yeah.
So we asked, when we had the companies, our trade contractors, we had them, the owners and their foreman. So we wanted the foreman, whoever was going to be the point person that Mike was dealing with on site, we wanted their foreman there. And so we've only had to turn over one subcontractor who couldn't keep up. So all the initial subs who we trained have been working on this job. We had to switch HVAC contractors because our HVAC contractor couldn't keep up with the certification process and because this is Energy Star, and this is so we've been very diligent about wanting that foreman one point of contact, and they know everything from that point forward. And so that's worked out well.
But I also think at the end of the day, it's still plumbing, it's still electrical, it's still HVAC. It's the airtight layer you got to be concerned with, and making sure that they understand that. And we've had lightning rod guys, and just kind of spend an hour or two, walking through them and saying, this is, hey, if you make a hole, you need to let me know, and this is how we have to deal with it. But all the guys, for me personally, I've worked with the electricians for this electrical company since almost 20 years, so I know most of the guys. And for the plumbers, I've worked with them for 15 years, so I know all the guys, and they're all responsible people. So we haven't had any where they're like just making holes and not doing anything. They've all been very responsible, and they understand the concept. I mean, they don't believe in some of the stuff sometimes, but, you know, you got to kind of, but everybody's been actually great because it is the next thing, you know what I mean? So they're going to be doing this everywhere.
Yeah,
And our HVAC contract, he's done a lot of this stuff already, so they're familiar with pretty much a lot of the stuff.
A lot of the trades are excited because they see that we're doing something different and this is the future. So we did we did do a lot of spreadsheets to say here's every penetration. So Mike and I did a lot of spreadsheets saying, okay, here's your basement penetrations, here's your first floor penetrations, here's your roof penetrations, and then making checklists and then assigning them to people and then making sure those all got reviewed by the CPHC. So we put a lot of work. You know, my job is really to keep Mike's on site, doing the micromanagement of all the guys, make sure it goes right. And I'm in the background always trying to think, how can I help Mike with, you know, keeping track of all this information that's coming and going, and how are we making sure that we're not losing anything in between. So.
Thanks.
Well,
I have to admit I'm a little bit torn about this project. You know, on the one hand, it's just, you know, it's a spectacular project. It's a beautiful house. You know, it sounds like a dream client, and an awful lot of tradespeople are getting a fantastic education in high performance construction. On the other hand, I keep remembering a few days ago, New Bedford Whaling Museum, they finished their annual marathon reading of Moby Dick. You know, it's a little bit of chasing the great white whale here a little bit. You know, it seems like this might be, it's hard for me not to think that this is really a misapplication of the Passive House standard.
Yeah, I agree. So when we say environmentally friendly, so this house initially, you know, when you look at, so part of the way I've looked at this house, you know, I've really been interested in, you know, I sat in Declan's presentation at the Passive House Symposium, looking at the embodied energy of these buildings, right? How much energy are we putting into this building? What's the carbon debt that goes into this building? And so part of what I'm conflicted about it because, you know, is this environmentally responsible to be building this way, you know? And so part of the way I look at this house is really built for, this house will be energy relevant for the next 100 years plus, right? This house is going to use, I think our peak load is 32,000 BTU. This is a home that could easily last 200 to 300 years, okay? So I look at it and say, well, we're building a house. Is this a misapplication? In some ways, yes. In the other ways, the only people who are going to be the early adopters of this stuff are people with money in some ways, right? So this is a great opportunity for a lot of people to learn how to do this. Is this a scalable model or anything we want to encourage people to be doing in the long term? No, if every couple, this is not downsizing. I mean, this is a McMansion, and in as much as we might try to use environmentally friendly materials, the carbon debt of this building is, you know, it's enormous. You know, this is but if it lasts 300 years, the house we deconstructed, so there was a house on site that the client grew up in, the Whites. We deconstructed that house. That house only lasted about 60 years. And it was taken apart. It was totally, you know, the structure wasn't any good. The mechanical systems weren't any good. We deconstructed it. We recycled about 80–90% of it. So part of that I think is interesting about this house is this house could be a house that could easily last 200 to 300 years and still be, you know, you have to change out the HVAC system with the mini split heat pumps, but the windows are, you know, it's a Unilux window that's supposed to have a 200+ lifespan. I mean, the exterior shell of this building is as good as it's going to get in terms of residential building. So in some ways, I think it's a model for buildings that can last a long time. And if you averaged out, if you took a building and averaged out the, you know, the embodied energy over the lifespan of the building, I don't know that, you know, how that would look. But so I am torn that this is, you know, when people look at this as Passive House, it could give it a bad name and that like, oh, that's what, this isn't really the essence of Passive House. PHIUS really wants to encourage people to build smaller, build more, you know, but you know, that's not the project we were handed, and we're just trying to make the best of what we've been, you know, given.
How many square feet inside the envelope?
Inside, so according to PHIUS, the TFA, so the treated floor area, which includes the basement space and the unfinished attic space, is 4,200 square feet. But then you have a 3-car garage, and you have an octagon sunroom, which is outside of the envelope. So really,
So what do you think? What's your projection, square foot price?
just square foot price. I mean, I think the cost of this building will be more than $3 million. I'll say that.
So your comment is actually completely off-base. This is middle of the road.
Yeah, no, he's not off base.
No, it is middle of the road.
No, I don't care about cost. You know, because I'm in your camp. I'm sorry, Paul.
But I think it's I don't think Passive House was a useful standard for this project.
Yeah, I don't think the house was a useful house for the I wanted to say the reverse of what you just said. But not that mean. I'll get mad. No, so my two takes, and I'm with Paul. I'm torn. One, because I like the guy, but two, I think the problem. One of the big problems I have with this is I can't walk away and say anything there is replicable, right? I mean, what do I take away from that and use on another project? And I say that based on my second comment, which I think this is exactly a great example of application versus integration. So you had somebody with an idea for a house, and then you tried to apply Passive House to it. And from where I sit, it seemed like you were chasing your tail from the minute the excavator hit the ground.
But what if it wasn't Passive House? It's just basically what's the highest energy efficiency you can achieve with this giant house.
No, but there's a series of decisions that were made that led you to further decisions that had to be made based on something you decided a year ago. That if that had been changed, it would have changed a whole bunch of other decisions.
Yeah, if we knew now about Passive House, there's no way we would have allowed this design. We would have been able to lobby the client to modify the design to make it, because then the other option you looked at, believe it or not, was a boxy, modern, it was just like as modern as you could get. So Mike and I look at it going, it would have been so much easier if we could have gotten him to go that way.
It's not so much the house style.
Tell them how we do that.
It's not so much the house style.
You gotta pick your poison next.
It's the consciousness that you approach the project with. That if you design the project and just say, and this is, I mean, we spent years doing this at Building Science, which was, it was modestly successful, but it was a horrible approach. Is that you just can't design a house like you normally would, and then just take that plan and that idea and say, hey, let's make this a passive.
That's the biggest lesson. I mean, the biggest lesson learned from this: don't start with the design and then make it passive. I mean, but that I can't say that now because I can't apply it right. So if I were going to say anything, it would be start with your passive design, start with your passive details.
Or start with that understanding.
Yeah, understanding, right. Yeah, and we sort of got, but, that's what's been interesting.
No, it is what it is.
It is what it is, yeah. But it's not definitely a model to say, hey, I recommend going this route. Why don't you start, why don't you start building and then work out your details? Mike's lost a lot of sleep trying to, we're trying to make up, but it's been, I feel very fortunate to have, been provided the opportunity, and the client understands that we're learning as we go. Like a lot of this stuff, like when we're wrapping that house in my coat, he understands that, when he chose to go this path, he was going to be paying for some of our education.
I mean, Fred's budget's the same as yours on his project.
I don't know. I think $3 million for this is a steal.
I think it's a real steal.
Yeah, I mean, there's definitely houses in.
I would have done it for double that.
A lot more.
Duly noted.
So your client was a physics high school teacher, and he was part of your integrated design process, right? He was there from the beginning. How much did he learn about Passive House concept, and did it in any way?
What we're trying, so he's very interested in this. He's really gotten caught up. He's been buying the Passive House books now, and when he reads them, he gives them to you. He goes, "You guys want this book?" So he's gotten caught up, and he's very interested in now. He loves it. He goes on the Nessie. If you're at the Nessie tour, I think I saw you there. He goes and he adds in his 2 cents during the presentation to tell us about stuff. So he's gotten caught up, and he really likes it.
He never had any doubts about the architectural concept.
No, well, we told him we can't guarantee we can make this happen. We're going to do everything we can. We're still in pre-certification. We're still going back and forth with PHIUS, as Mike said. We go back and forth with PHIUS. This has been a long process of trying to get it certified, and we're still, there's still a chance we won't get this, or we might get 99.9% of the way there, and we may get disqualified for some minor technicality. So he understood that we may not be able to get this, but we're going to do everything we can to get it there. And so,
I mean, the way I hear you say it, he really wanted a mini shuttle. He didn't want necessarily Passive House. He wanted the best energy performing mini French shuttle.
you could say it that way.
But we never really pushed the passive, and it was him that said, I want the certification. One day in a meeting, he said, whatever you got to do, I want the certification. So he's the one that kind of drove it further in that direction.
The scary thing is
you could be a high school physics teacher and not understand how buildings gain and lose heat in any level of detail. You know what I mean? I mean, it might not have been that awareness. I think he's developed it, but at some decision point, he may not have had that awareness.
Well, it's just my opinion. That image.
Huh?
he was too much in love with that image of the house he had.
I don't know if it was that or awareness. I can't speak for,
Yeah.
you know, what he was thinking, but I'm just offering a possibility. Many people that understand math and physics don't understand necessarily how houses gain and lose heat, or how very thick, steep assemblies are constructed, and the implications for all that. And there's a lot there that's not obvious.
And at each step of the way, we had to explain to the client, you know, if we can rotate it, you know, a few more degrees, we can get this way down, you know, and he'd say, I don't want to do that. And then we'd say, okay, well, if we can go 18-inch thick on the first floor walls, we can, you know, we looked at trade-offs, and those certain trade-offs he was willing to make, like, with the aesthetics, and certain ones he wasn't. And, you know, and so we're just trying to work with, you know, to push the envelope as much as we can without, you know, work within the client's desires.
Yep. I have a question on the integrated project delivery, and, you know, the wisdom is, which I want to ask you about, is that it's really, really helpful when you build a passive house, particularly, to have that kind of thing. If you go to the conferences on IPD, you know, that basically there's this method, and it's difficult to do. That doesn't seem to be your experience. You're dealing with guys that you've known a long time, and that the integration was not that difficult. I want to ask you about that. And the reason it comes up now is that I'm going to be meeting with people who have done a lot of training in non-construction industry, team building, and we want to bring them into passive house architects, builders, and so forth as aids to the team building process. And the question is that something which you people would have found important, or you say, basically, you've got the long-term relationship with all these subs, and that you don't need another layer there?
For me, to work with the subs was, you know, was easy. I think the hardest part of the integration team was the other people in the circle. You know what I mean?
I think the many you
and
don't
and just kind of making sure you allow those people to do their job, and you don't have other people like trying to do their job too. Like Nick said, no, not so much that. It's just that you had like the interior designer's got an idea, then this person wants to chime in on how the HVAC is being done, and another person wants to chime in on how the plumbing. So you know, there's just you know, you get into these big arguments over stuff that one person should be handling. That's why you hide it from his expertise, and you know, going forward.
Would you see a value in someone who's got an expertise in putting a team together and assessing what its functionality is and whether it's running into problems and correcting those problems?
So that's my job, right? My job is to manage the whole team and just see all the personalities and make sure everyone, like everything, I am CC'd on almost every email, so I probably got, you know, I track, I'm trying to keep in tune with everyone on the job, make sure everyone's working together. And so that's really my job. That's my job as the general manager. So, you know, because that's not really Mike's job. Mike's job isn't to be dealing with the interior decorator, the client, all these consultants. Mike's job is to build this, right? So that's really the general manager's job, is to manage the personalities, because it's the people. Mike's dealing with the work. I'm dealing with the people and a lot of the ideas, you know. So I think that would it have been good for us to bring in somebody else? No, that's really my job, is to, you know, make sure that, you know, we're finding the right people, and if people aren't working out, then I'm being clear with them that you're not going to work out, I'm sorry, or, you know, or keeping people in their roles, you know, working together.
But I would say this is not, as like Steve said, we kind of took a house and tried to make it passive. So I wouldn't say this is like the perfect example of integrated design team, because typically you would already had most of that stuff done before we went to the ground, and those, you know, a lot of this stuff would have been worked out within that integrated design team in the conferences, you know, and they would have settled all these, you know, came up with the details and worked everything out. Where on this project, we're kind of rolling with it as we go, and we're having to, you know, learn as we do it. So I think an integrated design team in the right, you know, use is probably a great thing. You know, especially when you have people like Mike DeClo, Mark Rosenbaum, people that, you know, understand all this stuff, you know, totally, and they can bring all that to the table. That helps, you know, everybody. I mean, because I've learned so much from Mark and Mike, you know, just on, you know, how things work, and, you know, me and Mike are, you know, and I know more about probes than I need to know about probes. You know, because, you know, but it's, you know, but I think, you know, I think it's a great way of doing it. If as long as you can get that team and everybody can pull, it's all pulling the same way, it can be a, you know, a great way to do it.
Hank has the last question, then we need to wrap up.
Last question, really kind of a comment. It seems to me that you can look upon this as being a misfit, passive house and a type of house. On the other hand, you could look upon it as almost like a retrofit. And we talk about how we're gonna do retrofit passive house on buildings. And those buildings are not going to be, inherently passive house. They're gonna involve all kinds of gymnastics, maybe kind of like some of the things we saw here.
We're actually planning a visit to an old structure in Boston for one of our meetings this summer, where we'll do a charrette about how to do a passive house retrofit on an old building. So it's a nice segue. Anyway, let's thank Nick and Mike. Very provocative. Thank you.
Nick, do you guys typically do masonry construction? Was that your first time?
No, work with Mike with our masonry.
Yeah. So we don't typically need our contractors have stucco, with fiber cement.
It's fine. I was curious if that was like part of the learning curve for you guys. Yeah, because it wasn't like a traditional detail.
Because the masons are installing the rock and the belt drive. Like all my work. How it's gonna work. Make everything. But also, I got the brick delivery. The brick delivery guy goes, I have a